Our speaker will be Ferenc Hegedüs. Ferenc is a vehicle engineer and an enthusiastic software developer with the main professional area of interest in automated driving. In the last decade, he was involved in the software development of various automotive products and pursued his PhD in motion planning for automated road vehicles. He is currently working on algorithms and validation methods for radar sensor-based environment models at Continental. Ferenc believes that a high level of automation of the development and testing processes, as well as efficient tools, are essential for delivering quality software to the customer in a timely manner. The title of the talk is Software Development Challenges in Automotive Projects. Please welcome with a huge round of applause, Ferenc Hegedüs.
Yeah, thank you. So, since it's very weird, I am not hearing myself. A quick audio check. Are you interested in automated driving? Please put your hands up. Yeah. And what if I would ask if you want that every time you or a family member or your relative travels by car, and you could be 100% sure that they arrive safely? Would you want that? Yeah. So, automotive projects are very complex, and because of that, basically, productivity in development is killed. Or is this really necessary? So, is this inevitable? I guess you already heard many times that automotive projects are very complex. And I guess you might as well agree, but did anyone tell you why are those projects so complex? Could you really list what are the key factors of this complexity? And regardless of automotive, have you ever felt that you cannot really concentrate on real development because you have so many side tasks that you have to perform that you really cannot concentrate on like creating features? And have you felt that, okay, I don't even understand why I have to do these side tasks because I don't see what's the point in doing them? And even if I see what the point is doing them, I don't really know how I could still concentrate on the features instead of these side tasks. So I understand I have to do them, but come on, I really cannot concentrate on delivering value to the customer and bringing new features. So in my speech, I will try to explain why automotive projects are so complex and why automotive software development is a challenging area. And then I will give you some examples how to be more efficient. And I think you can apply these to whatever industry you are in. Probably the sources of complexity will find out these are common between your business area and automotive. And probably you will get some hints to your developers to make them more efficient. So, a little bit of introduction. I'm Ferenc Hegedüs. I'm a software engineer currently working at Continental in radar-based software development. But I'm basically in automotive software industry since almost 10 years now. And I have a PhD from automated driving-related development. And a little bit about Continental in Hungary. So yeah, Continental is a tire manufacturer, of course, that one everyone knows, but it's not only a tire manufacturer, but a very important automotive supplier of different automotive systems. And here in Budapest, we celebrated our 5th anniversary last year, basically. And we have a development center concentrating on AI with a critical mass of knowledge about how to apply AI techniques in automotive projects. So, finally, my personal motivation to be in automotive after all these years is basically that I could contribute somehow to the society by providing solutions that make public transport, road transport safer. And this vision is formulated in Vision Zero, which is a vision of Continental that we would like to achieve zero fatal road accidents, basically. Yeah. I think I already explained this. So what are the sources of complexity in automotive projects and maybe in some other fields as well? Here I brought you some safety statistics about, from the EU. You can see the number of fatal, so deadly road accidents decreasing from 2000 to 2020. And you can see this is a nicely decreasing trend, but still in the EU, yearly more than 20,000 people lose their lives in traffic accidents, which is not very nice. On the graphicon, you can clearly see the effects of the pandemic, because then the traffic was clearly reduced. But then still, unfortunately, this curve is increasing, so we still have a lot to do. This decrease can be, so the evolving ADAS systems has helped a lot to decrease this curve, but we still have a lot to do. And the other chart is a collision matrix. You could see the number of fatalities in different crashes. And there are two important takeaways from this picture here. One is this blue rectangle, where you can see that actually many fatal road accidents come from accidents where no other traffic participant is involved. And what does this tell us? So these are even human errors or technical malfunctions, because there is only one vehicle that is involved. And the other part is the other rectangle, where we can see that pedestrians, cyclists, and motorcyclists are obviously very vulnerable. And why I would like to talk about this is that we can really well sense them with radar sensors, and I will talk about radar sensors a bit more later. Here you can see different ADAS functionalities which have been developed in recent years, so over the last decade, and how effective they are in reducing the number of accidents. And interesting fact is here that they even become mandatory in some cases. So, for example, electronic stability control is mandatory in the US and the EU, and also now lane change departure warning is also a mandatory accessory of new vehicles sold in the EU and the US. So these features, which are first starting as a very convenient comfort features, become actually essential safety systems as we evolve. Yeah. So we saw how important road safety is, but because of that, we have to apply many standards in automotive developments. And the two most important ones is regarding functional safety and safety of the intended functionality. One concentrates on random hardware failures and systematic failures of developers and hardware. And the other one is concentrating on explicitly on ADAS systems, which are using complex sensors and processing systems. To apply these standards, you really have to do very tiring and explicit work for evaluating the risks you have in the system, assign a risk reduction level to your product, and then find out the safety concept, find out what you have to do to reduce this risk to an acceptable level. And then out of this, in the development phase, you will have a lot of safety-related requirements, which are extremely important. And of course, it's not only safety, so there are many other social requirements nowadays. So safety, of course, is the most important one, but yeah, environmental friendliness. You can think about the climate change. Yeah, some say it doesn't exist, but I think we can all feel like the storms and hot weather all the time. And other thing is economic efficiency. So I think you all know fuel prices nowadays. It's very important to be efficient, not just because of the environment, but just because it's very expensive. And user-friendliness. And the resulting tendencies are that the complexity of the project is increasing, but we have to deliver in less time. So it's like in the opposite direction. It makes our work even harder. Yeah. Also, there is a transformation of business in the automotive. So in the old days, basically, That was component business, which meant that automotive suppliers basically sold hardware which contained some embedded software. So the main product was the hardware, actually, and you got the software with the hardware so that it works. And now it's not the case anymore, or it's not the only case anymore. It still exists, but with the evolving automated driving and higher level of automation, actually there is now software solution business where we want to sell software independently of hardware. So it doesn't matter if it's Continental radar or it's another radar from some other supplier. We want software to work on both. This increases complexity as well. And we are moving from advanced driver assistance systems to real automated driving, which is, again, a whole level of complexity. Yeah. And then, because of all this complexity, I guess you can also not read these. This is from ASPICE. This is the description of automotive processes, basically, and the V model according to which we develop. The key takeaway of this slide is that it's very complex. We have to do a lot of things in order to be safe. And as you see, the V model, it has 2 branches. And the point is that every step of the development process, you will have to test as well. So in every step of the project management, there is a testing phase. And there is verification on the left side and validation on the right side. What does it mean? Verification means that we are developing according to the specifications. And validation means that what we develop is actually working as we want it to work. And we do it like 100% verification, 100% validation. We check all the specifications, and we check everything. Now, with real automated development, is this really possible? So the possible number of traffic scenarios is really infinite. So we cannot do 100% verification, validation anymore. But our processes are not prepared for this. Yeah. So everyday work is not just coding, which I like personally. I guess developers like coding, but we also have to maintain traceability to the requirements, create detailed design first. We cannot just code, we create a design first. We have to document very strongly. We have to unit test very strongly. We have to evaluate performance very strongly. So that means from a 2-week sprint, the actual coding part is 1 or 2 days, and all the rest is this side task. And I don't know how much I remember to Mr. Incredible, that name. But yeah, the coding part is also according to very strict standards. So I don't know who programs C or whoever programmed C and knows QAC or not. This is a static code analysis tool that will check if your code matches some standards and rules, which makes life, of course, even more complicated. And then, of course, there is the technical complexity, which is the first one I think that everyone thinks of, is that it's very complicated developments technically. And I would like to show this to you based on the example of automotive radars. This is a typical setup of radars in today's car. So there are shorter range radars, which are looking around the car, and there is usually one long range radar, which is looking ahead of the car. And you can measure basically the range, the azimuth and elevation angle, and the radial velocity of objects. So that means you can locate the objects around you, and you can also directly tell their speed, which is a nice thing with radars. It has many advantages. Basically, radar is good in percepting everything that you, as a human, are bad in percepting, but radar is bad in which you are good. So it's really as the opposite of a human. So it's very robust against poor weather conditions. No daylight is needed for it to work. It directly measures your velocity. It has a very long detection range, and it can even detect objects that are hidden. So if multiple cars are ahead of you on the highway, it sees under the first vehicle in front and sees as well the next one and the next one. Of course, it's not perfect. It has some drawbacks. Its angular resolution is not that bad, not that good. So it's much better, much worse than yours. Yeah, and it has really a special role in safety. That's why I'm mentioning it, because it is very good in detecting all those vulnerable road users like pedestrians, cyclists. etc. Yeah. And here's the complexity. So basically, radar signal processing is a very complex thing. And the physical signals, so there is an electromagnetic wave. This is then transformed into a so-called 4D radar data cube, which is then later transformed to objects in a point cloud, which is then converted to an environmental model. What does this mean? That despite of, for example, a camera, you have pixels and you can identify, okay, pixel belongs to one object, that's very nice. Cameras are also complex, of course, but, or if you have a voltage measurement, it's pretty easy, right? But here, the physical signals themselves are really, really far away from what you derive as an environmental model. Abstraction level is increasing, and you get more data that you, as a human, can understand properly, and that you can use, like, okay, where are those cars? This is very far from the physical signals that you have. So the physical the data complexity that you have is huge. Yeah. This gives the special complexity, for example, in case of radar. And then, of course, we cannot really go without mentioning AI. So we at Continental also like using more and more AI in our development. But what is very important by AI is that the better it performs, usually, the less you understand the system. With deep neural networks, big language models, etc. It's not very understandable by humans. And you cannot really say that, okay, 100 times it was working properly, but for the 101 time where you have a tiny change, it will work. So it's very hard, and we have to concentrate not only on the performance, like, it's not like ChatGPT. If it says something stupid, okay, they will lose users, of course, but no one will die. If we make a mistake here, and we say, for example, go ahead, there is no object in front of you, emergency braking will not work, and we will hit someone. So really, we have to concentrate on robustness and verifiability of those things so that we can ensure that they are safe. Yeah. So I guess you can see now that these are really complex products. But what can we do to concentrate on the feature development and to be efficient and really so that we can deliver some stuff from time to time and we can deliver real developments? And here I would say, and I heard this today in many presentations, feedback is key. You see above a control loop, which is like, for example, cruise control in your car. The controller is the ECU that will control your speed. The actuator is your engine, and the system is your car. And the sensor is your speedometer that measures your speed. And you measure your speed, and you see, okay, am I traveling with the speed I want to? And if not, I will apply some more in the gas pedal, or an equivalent, or a bit less. And then the engine will produce more torque or less torque, and I will go faster, and I will reach the target speed, for example. What I wanted to say, if any part of this blockchain is not connected anymore, if we cannot sense how fast we go, if you cannot actuate the gas pedal anymore, if the engine is not working, this whole thing is not working. So if there is no feedback, it's not working. And the same thing is with software development. So what we do is usually we create a design, try to find out, okay, how to solve a problem, and then we code, and then we test. But it's very important not only to create some unit tests, but also to test the functionality. So you have to be sure that it's working fine. It's very important. And if some of this is missing, you cannot develop. As development is always an iterative process, because I don't know how many times you created one code that was working for the first time. It sometimes happens to me, but not very often. So it's very important that you can iterate, and that you can iterate fast. Yeah. And then about project management. I guess most of you is working in Agile, but Agile is, in my eyes, not equivalent to Scrum. And what I saw in automotive projects that, yeah, I guess we all know there is both Scrum and Kanban, but I saw with Scrum is that it has pretty much challenges because it has a very significant meeting overhead, and it has challenges, for example, with rapidly changing teams. Because Scrum builds on a team that already knows, where the developers already know each other. The whole idea of planning stories and planning story points and estimating, calculating velocities and stuff is working if you have a mature enough team. If you have new team members, like in every second sprint, if you're changing the teams in every PI, you don't really, you can't really take advantage of this planning. Also, with immature projects where the scope is changing many times, like we are in a conceptual phase, we don't know exactly what we want to develop, and the scope is changing. Like we try out, this is not working, and then suddenly someone comes with an idea, we have to try out that one. Then sprint planning loses its significance because you will have to change your sprints because the scope is changing that rapidly. And for me, like Agile means that you can be agile also in adapting these project management styles according to your needs. Like you don't have to do Scrum or Kanban, you can mix it, you can find out what fits to your team and really apply that. So it doesn't necessarily have to be like it's written in a book and you apply that and it should work, because I think we all know that these are not always working and we have to adapt them and find out what is not working for us. Yeah. Very important thing. Yeah, Agile also says we should have cross-functional teams, which means a team could be able to deliver really integral parts of a software on its own. So there are no, as we heard in the keynote as well, that business is going into this direction. There is not like someone who designs, someone who codes, someone who tests. There is no more like only front end, only back end. We have to do basically everything to be able to deliver some valuable parts of the software. But a cross-functional team doesn't mean that everyone can do anything, especially here in these complex projects. It's so complex technically that you cannot really do that. Specialization is needed so that you can be efficient. It's not valid that everyone can do anything. Also, which is very important, in my opinion, is that a clear ownership is needed. Like, okay, we have to have a first person to contact if we have an issue with something. And we have to know, okay, who is the responsible for that. And because the teams are like more self-organizing and they can do more on themselves. But you have to synchronize between the teams. And if you forget that, then you will have like one team who is building the bridge and another team on the other side of the river digging a tunnel. And there will be no real benefit of that. Also, I think it's extremely important that you have enabling teams which are like developing tools and services internally which make your development possible. Yeah. Also some consideration in the development process. So one thing which is, I think, very important, but we sometimes miss it, and yeah, I know we missed it, and I guess you also, that keep everything as close to the source code as possible. So code, detailed design. So for example, we program in C. We have our detailed design in Plant UML right next to the source code. Then we have our tests with Google tests also in C, C++. And then we have the documentation generated by Doxygen and have those. So everything is near the source code, which is good because if you want to know, okay, how does that work? You can check the source code. Everything is there. You must understand. Also, what is very important is that we should have single source of information. I'm sure you never saw that we have Teams, we have Confluence, we have shared drives and Word documents. we have like a company internal portal, and we have like 100 tools where we have pieces of information, and they are often contradicting to each other as well. And we then stand there and, okay, I just don't know. Where is this? Oh, I sent you an email last week or something like that. So it really should be in one permanent place with a clear structure that everyone could use it and find it. And it's very important that it's close to the code. Another advice. I have seen some very, very annoying internal tools at companies, like really a C development environment which was not able to find the declaration of a function if you have clicked on the definition. So don't use those tools and let the developers use the tools they like. These are some tools I like, but I'm sure you have yours. And I'm sure you have felt like, okay, I'm going to my colleague to help, but he doesn't have my special softwares and tools, and now I'm feeling pretty awkward. I don't find anything. For example, when I have to help my mother, she doesn't have a proper file manager. So then I have to open Windows File Manager, which I really hate and cannot use, and I'm not efficient with it. So it's important to let people use the tools that they are efficient with. And of course, licensing and security are to be considered here because, yeah, it can cost money and then you have to decide if it works. But still, like with open source stuff, just let the developers use what they want. Yeah. We are software developers. That means we have tools as softwares. So as a carpenter, would not like to create a table with a Smith Army knife, although a Smith Army knife is a very nice tool. I also have it. We need custom tools and proper tools to do our software development properly. And this is very important because sometimes you just concentrate on, okay, we have to develop the features in the product. We have to deliver to the customer this and that. But if you don't have the infrastructure, if you don't have the internal tools to be able to do so, you will not be able to deliver the code to the customer as well. So it's very important that you have the infrastructure so that you can efficiently develop. And you need tools for data management, for simulation, to compare the output, to evaluate performance. All those things should happen automatically. And we can say, okay, as we discussed, it's very strict to develop code that runs on the ECU, but then we can do whatever we want with the tools. Like we can use it as a trash bin and to put very unclean code into that because it doesn't matter. Yeah, that is actually not the case, and because these tools will be used to validate your work on the ECU code, so they are very important. Also, the functional safety standard has a tool qualification, so you also have to comply to standards with your tooling. Yeah. When to automate something. And there is this meme like, instead of spending 10 minutes to do something, I will automate it in 10 hours by programming. Who does that? I do that, yeah. But the thing is, it's not the only reason to automate that writing code to do it is faster. Of course, this is one reason, but you should consider automating something when you have repeated simple tasks, for example. You have to do it a lot of times. So really, writing code for it is really faster than doing it by hand. Okay, this is one case. But then you have simple tasks with many steps. And many steps, if you do it by hand, you are most likely to do something wrong. So it's better to automate it because once you automate it properly, you will not do it wrong by hand. Then, if you have a task that requires you to use many tools, like clicking around in Visual Studio, then clicking around in QAC, etc., it becomes again complex and very tiring for a human. And you don't want to do that. Let's automate it. And also there are complex tasks that would take you many time to perform. Yeah. So the point is, automation is not only required if it's faster that I write a code than if I do it manually. Yeah. Some tool development best practices here, what I saw in the years. Like, OK, how to decide which programming language to use. Then you should consider, OK, which platform operating systems do I want to use? Or what does it matter? The speed of the application that is mattering to me, or the speed of development? I want to use these tools for some general topics, or I want to do some very specific. Like, for example, I want to do some file managing, data management stuff, not too complicated, only in Windows. Then I would say use PowerShell because it's there on every Windows machine automatically. You will not have dependencies. You just write your script. If you want to do some AI development, like training deep learning models, go for Python because it has the most advanced tools for that. So it's really depending on these factors. Also, what I saw, logging. What I saw often, there is no log. You cannot find the error. Or there is 10,000 lines of log, and then you cannot see the error. So it's very important not to log everything, but log enough information so that you can find the errors. Also, if you run external programs, please log the command that you called. Like, how do you run that external program with which parameters? Because it will make error handling much more easier. Yeah, and the last, error handling, which is usually the most important thing and the most challenging part. One thing, mind white spaces and special characters in passes and encoding. I don't know how many times you meet this, but often there is this max pass limitation in the Windows pass that it's almost, or you can only use 250 characters in the Windows API. I cannot tell you how many times I had strange errors because of this. So we have to consider this stuff. Also, very usual, your scripts or programs should work. Doesn't matter which directory you start them. So in 99% of the cases, it's only working when you start it from its own directory. But come on. So it doesn't matter from which directory I call a Python script, it should work properly. Yeah. Also, check for the error codes of external programs. Like, I call some external programs, I let it run, and then I don't check the result. And then I have exactly zero idea if it worked or not. Yeah. Exception handling. Please don't write very big try-catch blocks with a catch containing a message that an error has happened. I saw this 100 million times. Only catch exceptions that you can handle on one hand, and never ever hide the original root cause of the exception. Yeah. Okay. One important thing is CI/CD. So you really have to automate properly if you want to keep efficiency. Because if the developers have to do all this stuff by hand, they cannot concentrate on developing features. So builds, code analysis, unit testing, functional testing, performance evaluation, everything should be automated so that you can really get feedback. OK, is my functionality working or not? And it's also very important that it's highly available. Like, if CI/CD is down in 3 days from a week, everyone is blocked. And it should be fast and informative when failing. So if there is a problem, the developers should be able to see what the problem is. And they should not dig into logs with 20,000 lines to be able to find out somehow what has happened. So key takeaways from my part are, like, these automotive projects are complex due to numerous reasons, like safety criticality, social expectations, and of course the technical complexity. And that feedback is very essential in both inside the organization and in the development cycle. And that automation and custom tools are key to keep focus on the functionality. Yeah, thank you very much.
Q&A time. Please make sure that you use this wonderful, beautiful QR code. And if you have any questions, here's your chance. Someone is taking a picture, so let's hope there's going to be a question. So we're just going to wait a little to see that. And we're going to be excited and fingers crossed. And usually this happens that, OK, it's Q&A, nothing. And then after some time, at the same time, the questions start coming in. So we're just going to wait a little. Until then, how was it on this stage? It's a very unique.
Nice. First, it's very interesting that you don't hear yourself on loudspeakers, but
I know.
I'm used to the noise because I did lots of teaching at the university, so.
OK, so that helps a lot, I guess.
Yeah.
I think 2 questions are coming.
Yeah, maybe.
Two people seem like very suspicious activities that could end up as being questions. Here we go. Here's the first one.
Yeah.
Do you see we ever going away from C and other low-level languages for embedded systems?
Very good questions. My wish is that yes. So currently, I'm in home projects experimenting with Rust. And I already know some, not automotive, but embedded developments with Rust. And I think it's a very nice language. And yeah, so I think there is a chance that we will move away from C. But considering the amount of code written in C and C++, I don't think it will happen soon.
OK, thank you very much. And we have the other question in. What are your thoughts about Tesla's vision-only changes?
I'm not sure I know which changes are we speaking about.
I have absolutely no idea. I'm in the field of soft skills, so I'm just reading what's written here. Whoever sent the question, do you want to specify somehow which changes? Yeah? Why not? I'm just going to wait. I'm just going to give you the...
Yeah, I mean, there are no radars anymore by Tesla. Only cameras.
Yeah, the cameras, like in the old times.
Processing all the information about cameras.
Yeah.
Thank you very much.
I thought this is the question, but I was not sure. Yeah. So yeah, on one hand, what we do is we use 99% our eyes, I think, but we also use our ears. So from the human perspective, it should be doable, right? Based on camera. On the other hand, in my experience, what I saw in automotive, we really cannot do that. It's just not good enough. So my opinion is that at least we need radars for a long time now. There are some advancements in the camera stuff, and also they are using emerging AI stuff there to process. Maybe if the capabilities of AI and the computational power will grow anything near the human mind, maybe we will be able to use only vision. Until then, I don't think so. Yeah.